Alright, hello everyone. Today we want to take a look at the silent PC build I did a while back actually, including self-made heat pipes. Let's take a look at the design first and then we go into the physical thing. So first of all we start our trusty Blender. I designed this thing in Blender and that's what I came up with. So what do we see here? We have the case, which is basically a U-shaped bracket. This one here. And on top these 4 circles, these are actually holes, so you can put your fingers in there and just carry it around. And the square holes here, they're just cosmetic. They try to resemble QR code alignment square. So on the side here we have a slot for the motherboard connectors like USB, graphics and network connectors, and on the other side there is a hole for basically the power and reset button. And these things here are basically to hold the motherboard. Basically everything is, there's the motherboard, and here we have the heatsink. So this is one massive heatsink here, and there's on both sides there's attachment screws here and here. So case and heatsink are just held together by 4 screws in total. So yeah. And also important is that the motherboard gets installed where the CPU is facing towards the heatsink here. I don't know if it's visible here in this thing. Probably not. But you see that all parts on the motherboard are actually facing towards the heatsink. So that will give an idea. And the idea here is that between the CPU top and the heatsink there's going to be a heat pipe, which is basically self-made, and I'll tell you later how it's done. So after designing this here, I had to make a plan to actually get this aluminium tin built. So that's a 4mm aluminium tin which gets folded here or bent along these 2 edges. And yeah, so after I got all these measures in Blender, I went and made a 2-dimensional plan, or actually a plan, in order to give this to the manufacturer of the aluminum case, basically. So there's a company here in Germany called Blechking, and normally they don't do these custom things. They just do square tins and have them bent along 2 edges in most of the cases. But they told me what diameters their tooling have in order to punch these holes in it and make these edges here. So basically what you see here in Blender actually got manufactured exactly the way it is here, right? And this is cool. So and this works by making this plan here in Inkscape So here's a 2D unbent piece of aluminum sheet, basically sheet metal. And the only thing here is these two blue lines. They represent the edges where they actually bent this thing, right? So all holes are in here, and every square in this raster or in this grid is basically a centimeter. So that's how the manufacturer got proper measurements for locations of all holes and the outline. Also in Blender I did some renderings to make it actually to see in advance how it will look, which came out this way. So this is how Blender renders stuff. And yeah, I mean, if you want to learn more about Blender and 3D modeling, check out the tutorial from the Blender Guru, and you can learn everything there about modeling, about rendering, about colors. And it's a very, very good channel for getting into Blender if you're interested in these kind of things. So that's basically all which happened on the PC, and now we can take a look at the real McCoy. And that's how it looks in real. So on the front we have this encasing here with some finger holes, and there's some spacing here to enable the airflow from the bottom out to the open top. On this side here we have the power switch reset button, and on the back side here we have our giant heatsink. Then on the other side exposes all the motherboard connections, and on the lower side here the power socket. Now let's take a closer look inside. On this side here is the open power supply, then an SSD card with an SATA connector. Here is the heat pipe for a 1050 NVIDIA graphics card, and down below is the heat pipe for the CPU. Now let's take a closer look how the heat pipes were assembled. Basically there are two square pieces of copper and a copper tube in between, and all three pieces get soldered together with a blowtorch. And in the middle of the heat pipe you see there's a screw in there, and the nut basically for the screw is soldered onto the heat pipe, because the heat pipe is not thick enough to hold the threading, so I had to solder a steel nut onto the heat pipe. So after having soldered the heat pipe together, but first of all, inside the heat pipe there's a quarter of a volume filled with sand and water. This is to create the vacuum in the process later. So the way it gets assembled is, first you solder one square on one side, put the sand in, then you solder on the other side, and then the steel nut gets soldered on top above a little hole. And after that the water gets in, a bit more than 10 milliliters in the big heat pipe for the CPU. Then the whole heat pipe gets heated up, so the water starts boiling and the steam comes out. And when that happens, the screw with a nylon washer closes the hole and seals up the whole thing. And when it cools down, the hot gas inside cools down and contracts, and this creates the vacuum. The nylon washer holds it really tight because it got heated up as well, right? So there's a lot of heat in this copper thing once you heat up the water, so the nylon washer is thermally deforming a little bit, so it really tightens up the thing completely. One important thing about soldering copper, and especially these three pieces together, is that if you want to put it in a vise, you need to thermally insulate the metal vise from the copper pieces. Otherwise the whole heat is going into the vise, and with your little blowtorch you're heating up the big vise, and the copper is not getting up to heat in order to solder properly. I think a piece of wood also does the job, so the copper and the vise is properly thermally insulated against each other. So I hope that was interesting for you, and it was certainly lots of fun to build for me and design. I learned a lot during this build, and if you like this video, please leave a like and subscribe for more cool stuff to come. Thanks for watching, and see you in the next video.